Hey everyone, it's me, Mr. G. I'm here to do a read along with you guys for the TCI Science Unit 2, Lesson 3. Let me do a screen share and let's get started. Okay, we're looking over here. All right. Hopefully everyone can see what we're looking at here. I'll make this full screen. Okay, here we go. So, ladies and gentlemen, today we're going to be, oh, that's too far. There we go. Today we're going to be looking at pages 64, which is down here, and 65, and then your assignment will be page 66, okay? So I'm going to go along and I'm going to read this to you, okay? So here we go. Again, it starts with text with notes. Number 3, weathering, erosion, and deposition. Okay, you may notice that deposition has the word deposit in it, so you can kind of think of as deposition as depositing soil, sediment, and things like that. Okay, here we go. What would happen if you hit 2 rocks against each other above a table? You might find crumbs of rock on the table. If you hit the rocks hard and long enough, you might even break off a large piece. Rock on Earth's surface can also crumble and change shape. Weathering. Earth's surface and its landforms are always changing. Many changes take millions of years. Weathering is one of these slow changes. Weathering is the breaking down of rock by interactions with Earth's systems. Wind carries tiny pieces of sand. They hit and rub against the rock and wear it away. This is an atmosphere-geosphere interaction. Rain, rivers, and ocean waves also carry tiny pieces of sand. They beat against the rock and weather it. Water also seeps into cracks in rock. The cracks expand when the water freezes. Eventually, pieces of rock break off and are carried away. Glaciers gouge out rock when they move over it. So gouge is kind of like ripping and tearing. These are examples of hydrosphere-geosphere interactions. Plant roots grow into cracks in rocks when the roots search for water. As roots grow larger, they expand the cracks and push apart the rock. This is a biosphere-geosphere interaction. Weathering changes the shape of landforms. Water moving through the geosphere can slowly hollow out a large area of rock. Some caves form underground when water trickles through the soil and rock. Sea caves form when waves weather rock at the base of cliffs. Wind weathered rock in the Sahara Desert in North Africa to create strange rock shapes. I might have read that wrong. Wind weathered rock in the Sahara Desert in North Africa to create strange rock shapes. Okay, and there's 2 pictures over here. Move myself over here. Okay, this first one on the top says, this sea cave was formed by weathering of rock. Sorry, I can't read that well. This sea cave was formed by weathering of rock cliffs by ocean waves. I went to the Sea Lion Caves in Oregon this past winter, and it was a gigantic cave inside. It's pretty interesting how the ocean can really carve out a cave big enough to fit an airplane in almost. And this second caption down here in this picture with the kind of reddish orange rock says, these rock formations were created when wind weathered the soft sandstone rock in the Sahara Desert. Okay, that was page 64. Let's move on to page 65 here. I do like this recording a little bit better than this last one. I'm gonna move myself back over here. Okay, this next section is titled Erosion. Sediments form from weathered rock. Form and from are almost spelled the same, mixed up there. Okay, start again. Erosion. Sediments form from weathered rock. What happens to the sediments? Erosion is the loosening and carrying away of weathered material from one piece to another. Wind in the atmosphere and water and glaciers in the hydrosphere cause erosion. They pick up the sediments and carry them away. The amount of erosion is greatest when the wind or water moves fast for long periods of time. It took millions of years for water in the Colorado River to weather and erode enough rock to form the Grand Canyon. Okay, and this last one, it kind of looks like deposition, but it's pronounced deposition. Okay, deposition. When moving wind, water, and glaciers in the atmosphere and hydrosphere slow down, they drop the sediments they carry. This process is called deposition. New landforms are created by deposition. Okay, I'm going to leave it there for now. I live really close to this river called the Carbon River, and it's really interesting to see how each year the erosion and deposition change. When I used to walk to the river, right when you got there, there was like an area of rocks. You'd almost call it like a rocky beach. You could go down and get really close to the water, or even get in the water if you wanted. But then a couple years later, that whole rocky beach got pushed down the river about like 200 yards, which is really crazy to think about. So where there used to be a beach, now there's just a river. And then where there used to be just a river, now there's a beach. Again, just over time and the flow of the water, it changes. It's pretty wild. Okay, so we were here at deposition. For example, rivers slow when they approach the ocean. They drop their load of sediments in the river bottom. Eventually, a river delta forms. A river delta is a large area of land at the mouth of a river. Soil in a river delta is often very rich because the river erodes nutrient-rich soil and deposits the soil at the river delta. New beaches form where sediments in ocean water are deposited. The shape of a river may change as soil is eroded from the outside of a bend and deposited on the inside of the bend, where the water flow is slower and does not push as had on the riverbank. Which is hard, but whatever. Glaciers deposit gravel and rocks at their front and sides before as they melt and shrink. Ridges of rocks form. The geosphere is shaped by the different Earth systems. Okay, and then up here we have a picture of a big river bend here. And you can see this whole area kind of looks like a sandy beach with some grass here. That's all been deposited by this river. Okay, here it says, erosion occurs on the outside of a river bend because the water is flowing faster there and rubs harder against the river bank. So that means like out here. So this part's all being worn away while this part's being built up. So it's kind of changing the whole shape of the river. Deposition occurs on the inside of the bend where the water flow is slower. Okay? And sediments are dropped. Okay? So again, rivers and their shapes can change because those interacting systems. So your assignment today is going to be, again, text with notes. It says choose a landform to research. You can use your student text to find information or find information on the internet. Draw a picture of this landform. So this may be kind of tricky with notability, but I don't know. Drawing a river bend shouldn't be too hard. Okay. And then it says write a short report on how this landform was formed. Include these terms: weathering, erosion, and deposition. Include any relevant Earth systems, such as the atmosphere, biosphere, hydrosphere, geosphere. Okay, so this would be the trickier part. Basically, it's asking you about, like, if you drew a picture of a river bend here, okay, and you drew a river bend here, okay, you just need to write like a paragraph about it, okay? So include these terms: weathering, erosion, and deposition, if they are applicable, meaning if they connect to your drawing, okay? And then include any relevant Earth systems, the atmosphere, biosphere, hydrosphere, geosphere. So basically tell what systems are being, I guess, are active in the creation of this landform. So here I would definitely say this river is part of the hydrosphere. And again, like the erosion of this bank and the deposition on this bank would be the geosphere. So again, those are the two spheres that I would say for sure. You might want to say, some of the biosphere here, these trees might affect it, but for sure hydro and geosphere interaction there. So again, that's just trying to like link those two together, or whatever systems may be in place there. Hope that makes sense. If it doesn't, just let me know. Send me a message and I'll explain it further. Good luck, and I hope this recording is better than the last one. Have a good day, guys.